right, here we go.
Bring it down.
You have a 95 on here. On 39. Yes. Focus. On 39. Find the coordinates of the circumcenter of ABC. Now, we started to do this problem yesterday, and that's where we got cut off. So, this one, not the best problem. And I don't think they're going to ask me anything this hard on the exam, but this comes from one of the last sections that we did. So I would draw a graph and just use a graph to do this problem. We have 3 coordinates for our vertices. Plot those points. So 1, 2, 3, 4, 5, 6, 7 on the x-axis. 1, 2, 3, 4, 5, 6 on the y-axis. So we have a point at 1, 0 for A. We have a point at 7, -6 for B. And we have a point at 7, -4. It was sprinkling at the end of the passage. All right, so these are 3 points. We have them. We're going to connect them. We have ourselves a triangle. Now, after we do this triangle, we need to draw in our perpendicular bisectors of each side to find our circumcenter. So again, perpendicular bisector. Easiest one to do is for this vertical line. Because we just need to split it in half. Guys, ladies. So split this in half. Since we have a vertical line, a perpendicular line to it would be horizontal. So we're going to have a horizontal line right here for segment CB. Now, we don't know. For the other 2 lines, it's not quite as easy. So first we need to find a point that is going to be the midpoint of one of these sides. So I'm going to use AB. For AB, I'm just going to count the difference. 1, 2, 3, 4, 5, 6. Split the difference, go 3 units. 1, 2, 3. So at 3 units, we have a point right here. All right. So I have my midpoint. Now, to do my perpendicular bisector, I'm going to have to go from this point and do the opposite reciprocal slope of this line. Well, this slope, if you look at our graph, you go down 1 over 1, down 1 over 1, right? It's -1. So we want a slope of +1. So either up 1 over 1 and get a point here, or down 1 over 1 and get a point here, but we're going to have a line. My graph is not very accurate, but something like that. So we had a point. We had this point. I could have used. I had, if I went down, that point I could use. Again, go over, and hey, there's another point. That point is at 2, -5. That's a point we're looking for. Now, do you have to do all that on the test?
No.
Again, I highly doubt they're going to ask you for that much. Most likely, they're going to give you a right triangle. They give you a right triangle, it's much easier to find because it's just going to be at the midpoint of the hypotenuse. So you won't have to do much work. The other thing, they could have given you a horizontal or vertical line. And again, doing our perpendicular bisectors. Now, perpendicular bisectors of horizontal lines will make vertical lines. Our perpendicular bisectors of vertical lines will make horizontal lines. So that would make it easy. Alright, so that's that one. 40 is much easier. 40 is asking us for a centroid. We actually had an equation for this one. It was the average of all the x's for our vertices and the average of all of our y's for our vertices. So you took x1 plus x2 plus x3, and then there's 3 of them, so we divide by 3. And then y1 plus y2 plus y3 and divide by 3. And that gives us our coordinate point. So our x values here were -5, positive 6, negative 1. Our y coordinates, negative 9, negative 3, and 6. So for the first one, these all cancel out. That's 0. 0 divided by 3 is 0. These are going to give us, let's see, negative 12 plus 6 is negative 6. Negative 6 divided by 3 is negative 2. Our coordinate is at 0, negative 2. On 41. On 41, DE is a mid-segment. There's a couple things we have to know about our mid-segment. Our mid-segment is connecting two midpoints. But the other thing that we need to know is that this line is half the length of the third side. So if we're writing an equal A here, we have to double this one to equal that one. So 2 times 3x plus 7 equals 13x minus 28. So that's 6x plus 14 equals 13x minus 28. Solve. Bring a 6 over this way. That leaves us with 7x. Bring a 28 over to the other side. That's 42. Divide by 7, and x is 6. Is that our answer? No. Again, what is BC? We have to plug it back in. BC is this side here. So we need to plug it into that equation. So 13 times 6 minus 28. That's 78 minus 28, which is 50, which is D. For 42, what is the perimeter of the triangle? So, on here, we know one side right now. We don't know these two sides. These two angles are congruent. So that makes this an isosceles triangle. The sides across them have to be congruent. So we're going to set these two sides equal to each other first. 2x plus 4 equals 3x minus 2. Subtract the 2x. That leaves us with just x. Add the 2. X is 6. We need to know the length of these sides. So we have to plug it back in. You can plug it into either one and get the same answer. 2 times 6 plus 4. 2 times 6 is 12, plus 4 is 16. If I plug it into the other one, 3 times 6 is 18, minus 2 is 16. So that's 16 and 16. Now, for these, right, we have 16, 16, and 5. Add them up, that's 32, plus 5 is 37. So again, added them all up. 5 plus 16 plus 16 equals 37. That's our answer for our perimeter.
37?
37.
Okay, I didn't say it that way. What?
All right. Questions here before I can move it?
I'm not a big
Huh?
for that type of thing. You would have stupid.
I will. All right.
That is such a good story, sir. So, actually,
All right, the next two. So our number,
hey, I'm just looking at this phone.
yeah. So 43. Which point of concurrency is C? They drew segments that are perpendicular to the sides and go to vertices. So these would be our altitudes that are drawn in. Which one of these is for our altitudes?
Which answer?
Yeah, which answer is where the altitude be? That's what's drawn Nope. 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 Orthocenter. That's where all the altitudes meet. Again, we didn't have any special properties. We just had the name that we had to remember for that one. So again, the parts that go with these, circumcenter is where the perpendicular bisectors meet. The incenter is where the angle bisectors meet. The centroid is where the medians meet. And the orthocenter is where the altitude meets. All right, then on 44, we have which of the following statements is false? All right. So go through all the statements. The incenter of a triangle is equidistant from the sides of the triangle. That's true. Again, the incenter, center of the inscribed circle, it's going to touch each one of the sides exactly one time. The circumcenter of a right triangle is on the triangle. That too is true. When looking at all these points, two of them, the circumcenter and the orthocenter, have a chance of being either inside, outside, or on the circle. A right triangle is going to be on the circle. A acute triangle, it'll be inside the circle. And a obtuse triangle, it'll be outside the circle. The incenter and the centroid always have to be inside the triangle. So on the next one, C, this one, the incenter of an obtuse triangle is outside the triangle. See, that one is false.
This right here? I will go.
And then D, the circumcenter of a triangle is equidistant from the vertices of a triangle. That is also true. Again, a circumcenter is the center of the circumscribed circle that goes around the outside of the triangle going through the vertices.
Why would you do that?
Now, on 45, the triangles in the diagram below are congruent. They give us a congruency statement. What is the measure of angle N?
Just come sit up here.
Guys. Hey. All right. On 45. Match them up. So J goes with what angle over here? Why do you say M? That's 60, that's 56. Those don't go together. Which one does J go with? Oh, how do we know that? Oh, in the beginning of that statement, right? That's written in corresponding order. So this one also has to be 60. We want to find N. So we have 2 out of 3 angles. How are we going to find the third angle? Okay. We know all of them have to add up to what? 180. So we're going to take 180, subtract off the 2 that we know, 56 plus the 60. 56 and 60 add up to 116. What's left? That's going to be 64. That's going to be our angle measure for N. On 46, this one was tricky because if we look at this statement tells us how they're set up. On the 2 triangles, they're not set up in the same corresponding order. So F and J go together. So these 2 go together.
With all of
So let me finish this thought. So for those two, you have our 2 angles. That are congruent. We have these 2 sides are going to be congruent. Those are the parts we have to know. However, we don't have enough information there to solve yet. This one is equal to this. So we have the y that we need to solve for. This one's equal to that. Well, there's nothing over there. Somehow we're going to have to solve for x first and then the y. In this triangle, we have 2 out of 3 angles. So first, all the angles here have to add up to 180. So 180 minus the 2 that we know, 138 plus the 120. That's 180 minus 158. Leaves us with 22. this angle. Now we know this angle is equal to 22. So now we have something to solve. Let me break this check.
How was it inappropriate? You got a dog. We actually wrote something.
Thank you.
Oh, it's this one? Yeah, it's a baby. A baby snake. Oh, so it's purple. What? Because he was gonna say black. You know, people had a weed to. No, I'm thinking of a snake. He thinking something else. You're trying to say
So, you said equal.
See, I told you. I told you it was one of the two. You know, you're
Add.
busy.
Divide. We got x. Once we got x, now we can solve finally for this other piece. Now, this is not the best or easiest question. These two have to be equal to each other. We now have an x value, so we can plug it in. We have 1/4 times 10 plus y equals 14.7. So 1/4 of 10 is 0.4. Subtract off the 0.4, and you got 14.3. And that's y. Wait, did I do something else?
Oh, now it's okay, guys.
Oh, sorry. I did not. That's not right. I did. That's not right. 0.4 is not right.
See, this is hard.
Let me try that again.
You're gonna say it again. Let me say it again. He's a hard eye.
10 divided by 4 should be 2.4.
Wait, don't erase it.
No,
Oh.
I made a mistake.
Oh.
I put 0.4. Right? 10 divided by 4. Goes into it twice. 2 left over. 204.
Say the word.
2.5.
Say the word. Do I have to listen?
2.5. So subtract that, and it's 12.2. That's good.
So you get a thing over
Alright.
but not.
That could, so, wait, that's our answer. What's our answer?
So here I multiplied. So we got 10 times 1 is 10.
your phone.
Divided by 4 is 2.5. Subtract that from both sides. And that left us with 12.2.
No.
It's fine.
Questions on those 4?
No.
Alright.
What?
What?
Okay, you said 5 seconds. You said it's violent. Solid stuff.
On 47, point P is located at 4/8 on a coordinate plane. If a reflection is performed, identify the transformation that would map point P onto coordinate P prime of 4, -8. So they want to know which reflection was this? Well, what changed? The y value changed, right? So that'd be a reflection in which axis? That'd be reflected in the x-axis. The opposite value changes. If we reflect the x, the y value changes sign. If we reflect the y, then the x value changes sign. So on here, the y value is changing. This is reflected in the x-axis. All right. On number 48, a triangle has vertices at those three locations. Which transformation would produce an image with these vertices? So look at how they change. This value changed.
But it's easy.
This value changed. And this value changed. Signs, right? The only thing that changed was the sign. They stayed in the same spot, but they changed signs. So this time the x value is changing. So this would be a reflection in the y-axis.
What's in front of it, bro?
No, I already did. I already know you got it. Anyways, come here, bro. Come here, bro. We need you for something important.
Okay, I'll come back.
Yes, you. I don't need your phone number.
Nope. And different person phone. All right.
I'm going on the floor.
We good on 48? All right, let's go to 49, next page.
My God.
All right, on 49, the graph of a figure and its image are shown below. Identify the transformation to map the image back onto the figure. So, on this one, what type of transformation is happening here? A translation, all right? On this one, what type of transformation is happening? A reflection. Good. On 50, which transformation of the line x equals 3 results in an image that is perpendicular to the given line? So, is a reflection in this line? Is there a reflection over the y-axis, reflection in the x-axis, or reflection in the line y is equal to x?
I'll pay you. I'll pay you.
Yeah. Again, we reflect in the line y is equal to x, we switch the x and y values. So instead of having the line x is equal to 3, it would have been the equation y is equal to 3.
First of all,
Guys. All right, on 51. So, a reflection over the x-axis maps triangle ABC to A prime, B prime, C prime. Do the image and the pre-image and image have the same size and shape? Do they have the same size and shape? Yes, because again, a reflection is a type of what? Well, there's some names for that type of transformation that we should know. So if it's same size and same shape, we talk about rigid motion or a congruency transformation. So again, a reflection, a rotation, and a translation are all considered to be rigid motions or congruency transformation, which preserve the size and shape of the figure. So on here, which one's correct? There's only one answer here that says yes. Yes, reflection preserves both both angle measures and length of size. Again, it's the same size and same shape. So it's all true. All right, on 52. Quadrilateral ABCD has vertices at those 4 locations. Vertex B is translated coordinates up, and the other vertices do not change position. How much larger is the area of the quadrilateral? Wait, what?
Stop touching me.
Yeah. I think they screwed up on this question. I really don't think. That question doesn't make sense. Give me 1 second.
Yes, yeah. I need you to make me one more point. I gotta write something. We're gonna write. All right, we can do.
I don't know why there's anything like this, because this was not.
I did it, all right, the day after.
Alright. The actual test,
This is that you said 2 hours, do the thing for us.
test, you have like over 2 minutes per question. Now, for these, again, you gotta remember, some of these questions are asking multiple things in one. They're not all gonna be this long. Alright, for 52, this one is kind of a strange question because it's not something that we really cover. I feel like this is more when we get into area later on, but if we were to do this, we could graph all those points. So we have -1, 3, 1, 1, 2, 3. So we have a point here. Then we have a point at -1, 7, 1, 7. 3, 4, 5, 6, 7. Right. Next, we have a point at -5, 7. 1, 2, 3, 4, 5, 7. We have a point at -5, 3. So this was points A, B, C, and D. All right. It said B is translated 4 units up. So right now we have a rectangle. We went 3 units up. 4 units up. Sorry, 4 units up. Now we also have a triangle on top. The length here is 4 units. The length here is 4 units. Have I talked about area at all? That's the next semester. All right. So I really think this is a bad question because you should have a question about dilations. This is not dilation. This is only changing 1 point. Why are we talking so much? Shh. Just quiet. It's like you guys don't have an exam next week. Oh, wait, you do.
We do?
Yeah. I just got done saying this will be my only class that finishes all the problems, but you're ignoring like all the work that.
Well, no, I'm doing it.
Okay. Sit down, guys. You don't even have a review on your desk. I do. You might want to check your work. That's the whole reason why we're going.
I took other things.
Hope you didn't lose it.
No,
You gotta make sure you turn in at the end. Okay. That's another grade. Yeah, so it's 5 grades. 4 turns online and 1 giving it to me at the end. All right. So what you have to recognize here, though, we have a rectangle, we have a triangle. The dimensions on this triangle are the same dimensions as that rectangle, so this is half of the area of that. So they want to know how much larger is this entire quadrilateral than the original? It'd be 1.5 times larger. Which again, that's more of an area question. We've done an area like that, so I don't even think that should be on this review. All right, going on.
We don't clear yet. Oh,
There you
thank you. Put your head down more. Thank you.
All right, so the next set. With vertices, so again, they gave us 3 vertices, and so it's dilated by a scale factor of point.
Good afternoon. Please pardon this interruption. At the bell, students who are assigned to a they're
Yeah.
relocating